Good morning. Today we will be discussing very important topic of igneous pathology, that is the classification of igneous rocks. Now for the systematic study of the rocks, the classification is necessary and the various bases of classification are the geological occurrence. Once we say the geological occurrence, it means that is your mode of occurrence, that is geological occurrence or the mode of occurrence. On the basis of mode of occurrence, igneous rocks are classified into three categories. Volcanic, right? Volcanic means the rocks, because they are erupted on the surface, so they have fine grained or glassy nature. And once we say the fine grained means the volcanic rocks, the character is that they have the fine grain size or zero grain size. Then the second category or mode of occurrence is the hypobasal. Hypobasal means at least these rocks have crystallized at least two places. And the third category is the plutonic rocks, means they have crystallized at depth and hence they have coarse grain size. Examples of volcanic rocks are your rhyolite, basalt, trachyte, right? Whereas that of the plutonic rocks are your granite, gabbro, etc. Now the second category is on the basis of the, or you can say the second is on the basis of the textures, right? So textures, this is the textures. On the basis of the textures, igneous rocks are classified into three categories. That is phanerites, means if you can see or visualize the grain size with your naked eyes, that rocks or such rocks will be classified into category phanerites. Without aid of any instrument, means if you can see the grain size with your naked eyes, means the rocks are the phanerites. And your common examples, naturally they are the plutonic rocks are granite, gabbro, syenite. But if you cannot see the grain size with your naked eyes, but you can visualize under microscope, such rocks will be called the aphanites. And the third category, where the grain size is, you can say grain is of zero grain size, the rock is totally of glassy, that will be called the obsidian or the pitch stone. So on the basis of the textures, igneous rocks are classified into three categories, that is your phanerites, aphanites and the glasses. And on the basis of the mode of occurrence, they will be classified into volcanic, hypobasal, plutonic. Now coming to the second category, that is your mineralogical composition. So on the basis of the mineral composition, that is the percentage of the dark minerals, igneous rocks are classified into your four categories. Means your dark minerals or the mafic minerals, if they are restricted or limited up to 30%, that rocks will be called the leucocratic. Leuco means light colored rocks. The second category is mesocratic, when the mafic minerals, they are from 30 to 60%. Right? And naturally the rock will be neither light, it will be partly light, partly dark. Means they are almost in equal amount, that is the felsic and the mafic minerals. And third category, melanocratic, when the dark minerals, they are from 60 to 90%, means they dominate. And the fourth category is your hypermelanic, when the dark minerals or the mafic minerals are more than 90%, naturally the rock will be dark colored. So this is on the mineralogical classification, that is leucocratic, mesocratic, melanocratic and your hypermelanic. Now the next basis of classification will be on the basis of the chemical composition. On the basis of the chemical composition, there are the various parameters. You all know that igneous rocks are mineralized in terms of your silica content. The most dominant oxide is your silica. So on the basis of the silica content, your igneous rocks that are there, means if a rock has silica content more than 66%, that will be called silicic or acid igneous rocks. If the silica is from 52 to 66%, that will be intermediate igneous rocks. Then third category, basic, where the silica is from 45 to 52%. And the fourth category is ultra basic, when silica is less than 45%. So these are the four categories of, or you can say classification of igneous rocks on the basis of the silica content: silicic or acid igneous rocks, intermediate igneous rocks, basic igneous rocks, and the ultra basic igneous rocks. Now the next is on the basis of your saturation principle. Saturation principle, you all know that igneous rocks, saturation principle means, once we say saturation principle means, if the category that the rocks are divided into three categories: oversaturated, saturated, and undersaturated. Now what it means oversaturated rock means that on the basis, this classification on the basis of your saturation principle. Now the saturation principle says that the minerals are divided into two categories, that is saturated and the minerals which are capable of existing in presence of free silica, they are called saturated minerals. The minerals which are incapable of existing in presence of free silica, they are called the unsaturated minerals. For example, your feldspars, they can exist with silica, right? They are called saturated minerals, whereas olivine cannot, so it is unsaturated minerals. So taking that into consideration, the saturation principle harms. The igneous rocks are divided into three categories. Oversaturated rocks means the rocks can have quartz as an essential mineral and the saturated minerals. Second category means the rocks have only the saturated minerals, not the silica. And third is undersaturated, means minerals like olivine, nepheline cyanide, nepheline, etc. are there in that rock. Now the next is on the basis of because once you analyze igneous rocks, the most dominant oxide is your SiO2. The next is your alumina Al2O3. So on the basis of the Al2O3, the rocks, because the Al2O3 is consumed or utilized in the formation of your feldspars, so on that basis igneous rocks are classified that on the three, that is your paraluminous rocks. Paraluminous means when the total Al2O3 is more than Na2O, K2O plus CO. Such rocks are called paraluminous. The second category is metaluminous, when the rock has Al2O3 more than K2O plus Na2O, but less than Al2O3 is less than K2O, Na2O plus CO. Third category is subaluminous, when the rock has Al2O3 less than, or you can say the almost equal, Al2O3 is almost equal to K2O and Na2O. And the fourth category, peralkaline, when the rock has Al2O3 less than K2O plus Na2O. So these are you can say the various categories on the basis of your Al2O3. The next is on your CPIW norm. Okay, this is on the basis of the CIPW norm. You all know that from the chemical composition of the rocks, normative minerals are calculated, and the normative minerals on the basis of the percent of salic upon famic minerals, the rocks are categorized into persalic, dosalic, selfamic, dofamic, and perfamic. When salic upon famic ratio, salic is equivalent to your felsic minerals, which are actually existing units, normative minerals. By set of rules, the normative minerals are calculated, that is CIPW norm, given by the Cross, Eddings, Washington, and Purcell, right? So that is the normative minerals, they are calculated in the norm sheet, and the ratio of salic upon famic is considered in this classification, and if the ratio is salic upon famic is more than 7%, the rocks are persalic. If the ratio is from 7 to 1.66, it is dosalic, and if the ratio is from 1.66 to 0.60, they are the selfamic. Diphamic when the ratio is from 0.60 to 0.14, and the perfamic when the ratio is from 1.4 to less than 1.4. Right? So these are the different categories on the basis of the normative minerals, and they are indicators of, you can say, the composition of the various different normative minerals in the rock. So this is an interesting, and you can say, the classification on the broad, so you can say the synopsis of the classification. We will take detailed classification in the next video. Thank you very much.